Okay, let's review the first half of our algebra unit. We're going to start by going over powers, what they are, what they mean, and how to solve them. So when we have a number here, 2 to the 4th power, there's two terms that we need to keep in mind. They are exponent and base. The large number is our base. The smaller number in the top left-hand corner, top right-hand corner, is exponent. Now when we have an exponent, it means that our base is being multiplied by the base as many times as the exponent says. So because 2 is our base, that's the number being multiplied. Because 4 is our exponent, that's how many 4s we need to have. That's how many 2s we need to have. Excuse me. Now when we solve this, we can just go in order. 2 times 2 is 4. I haven't used the rest of this, so I'm just going to drop it down. 4 times 2 is 8. I haven't used this times 2, so I'm just going to drop it down. Now I have 8 times 2, which is 16. So that means 16 is the value of 2 to the 4th power. Value is a word that we're going to be using a lot. Instead of answer, we will say the value. Many things can have values. Exponents can have values, expressions can have values, and variables can have values. Let's do an example together. Let's say we have 3 to the 3rd power. I want to write out the expanded form. Expanded form is when we do the multiplication problem that represents the power. So here, 3 is the number being multiplied. And because my exponent is 3, I will multiply my base 3 times. 1, 2, 3. 3 times 3 is 9. 9 times 3 is 27. So 27 is the value of 3 to the 3rd power. 3 times 3 times 3 is the expanded form of 3 to the 3rd power. Very good. Let's move on. The biggest part of algebra is learning the steps of the order of operations. So in order, they are parentheses, exponents, multiply and divide, add, and subtract. So parentheses look like this. They can also be represented like this, with brackets. Sometimes they are these fancy looking brackets. Exponents, we already know what exponents are. Multiply and divide. This is the same step. So when you have a problem and you have division and multiplication in the same problem, you do it from left to right. You don't multiply and then divide. You do multiplication and division, whatever comes first, and then the next one, and then the next one. Same exact thing with addition and subtraction. You don't do one and then the other. You just do whatever comes first in the problem, from left to right, just like reading a book. Let's practice the order of operations. Our first expression here says 36 minus parentheses 4 plus 8 divided by 4. I'm going to come over here and I'm going to write out PEMDAS. So parentheses is what I saw first. So I'm going to underline the parentheses. 4 plus 8. That's 12. I can keep the parentheses if I want to, but I don't have to. Now, I drop everything that I didn't use down. Next, I look at exponents. I don't have any exponents, so I can skip that step. Multiply and divide. I have divide, so I'll do division first. 12 divided by 4 is 3. I'm dropping down 36 minus because I haven't used it. I have no more multiply and divide. My very last step is to add and subtract. I have subtraction here. 36 minus 3 is 33. So 33 is the value of my expression. Let's do another one together. 6 minus 1 times 4. In this expression, I'm going to go ahead and change the fact that there's an x here for multiply. In algebra, we don't do that because we need to get used to the idea of variables. Now, parentheses comes first. I don't have any parentheses. I don't have any exponents. Multiply and divide. I have 1 times 4, which is 4. I didn't use 6 minus, so I bring it down. Notice how my answer replaces what I solved above. Now I add and subtract. 6 minus 4 is 2. That is the value of this expression. Let's move on to the next part of algebra. Parts of an algebraic expression. An algebraic expression is an expression, which means problem, that doesn't have an equal sign. So an algebraic expression is an expression that has at least one variable. A variable represents an unknown number. It's a symbol. Most of the time, you're going to see these symbols as letters. So our variables here are x and y. I'm going to separate them with a comma. Next, I'm going to focus on terms. Terms are the parts of an expression. So it's the units that's being worked with. So it's everything except for the operators. Again, you separate them with a comma. 2x, comma, 3, comma, 4y. Now that I know terms and variables, I can identify coefficients. Coefficients are numbers in a term that have been paired with a variable. So here I have 2 of them. 2 has an x with it, so it's our first coefficient. 4 has a y with it, so it's our second coefficient. Lastly, constants. Constants are the opposites of coefficients. If coefficients have a variable, constants do not. Our only number term here that does not have a variable is 3. So it's our only constant. Translating verbal expressions just means taking a statement or a sentence and turning it into mathematical terms, like numbers and operations. So let's look at a couple of examples. 5 more than twice a number. So 5 more than. 5 more than can mean plus. twice a number. So 2 times a number. And because we don't know what number, remember that a variable represents an unknown number. So we're going to use a variable. 5 plus 2x. And earlier, remember I said that we use x as a variable now and not as the multiply sign. The reason I can put 2x and not 2 times x can be explained up here in our parts of an algebraic expression. The invisible operation here that you don't see is times. When those numbers, when those coefficients are touching their variables, that means times. Always remember that. Touching means times. Let's do another example. 5 divided by twice a number. 5 divided by twice a number. We had that same one up here, so we know it's 2x. 2 times a number decreased by 5. 2 times a number. Well, we know that's 2x decreased by minus 5. Four times the sum of 3 and w. So this time it gives me a variable. Let's start at the beginning. 4 times, so 4 times the sum of 3 and w. Sum means adding. So 3 and w are being added. Now let's not forget PEMDAS. If we solve this in order, parentheses, exponents, multiply and divide, we would be doing 4 times 3 first. But it's not 4 times 3, it's 4 times the sum of 3 and w. So there's something we have to put here to make sure that the sum happens first. The way we do that is we do parentheses. Now, in PEMDAS, you would do parentheses, exponents, multiply, divide, add, subtract. Just like that. Let's end on a simple note. X decreased by 5. X decreased by 5. So for this, translating verbal expressions, it's really just important to understand how mathematical words work. Let's look at some more questions so we can practice the order of operations. Remember, it's PEMDAS. A good way to remember this is please excuse my dear Aunt Sally. Parentheses comes first. I'm looking inside of my parentheses. 2 times 3 is what's inside of the parentheses. So 2 times 3 is 6. Everything I didn't use drops down. This exponent of 2 attaches here because it just drops down. Minus 7. Exponents comes next. 6 squared. 6 times 6 is 36. Minus 7 drops down. 36 minus 7 is 29. Let's do a more difficult problem to better prepare you. We're going to focus on 12 minus 6 plus 7 times 4 plus 4 squared. I know I start with parentheses. Inside of parentheses, you also follow PEMDAS. So I don't have any parentheses inside of here, but I do have exponents. 4 squared means 4 times 4, which is 16. Now I'm still inside my parentheses. 4 plus 16 is 20. Notice how I only replace what I underline from the previous line. Anything I'm not using drops down. And I just keep going. I don't have any exponents. Remember, touching means times. So 7 is touching the parentheses 20. So that means 7 times 20. My next step is multiply, divide. All I have here is multiply. 7 times 20. And that equals 140. Everything else just drops down because I haven't used it. My next step is add, subtract. I go from left to right. 12 minus 6 is 6 plus 140. Six plus 140 will be 146. I'm out of room in my little box. That's why I underlined it weirdly. There you go. That's all the time for today, but that's the end. Thank you very much.